Hey, hello, you're welcome to my channel. Thank you for watching this video, and I believe whatever you're going to watch right now, you're going to like it, okay? And when you like it, please don't forget to subscribe to my channel. Just press the subscribe button, the red button there, okay? It's actually free. Just press it up, and if you want to get some notifications from us, you turn on the notifications as well. Good. Okay, I just wish you the best of luck as you go ahead and watch the video, and don't forget to subscribe. You can even do it now so that you don't forget. All right. Okay, and now in this video, you want to find this infinite series using geometry, okay? When I say geometry, I'm not really talking about a very big kind of stuff, okay? I'm only talking about a shape. And in this case, we're going to be looking at a rectangle. Good. Okay, so let's look at what we've got. In each of the terms, we have some terms, okay? In the denominator, you can see they are like powers of 2, okay? The first one is like 1 over 2 to the power 0, which is 1. The second one is 1 over 2 to the power 1. The next is 1 over 2 to the power 2, 1 over 2 to the power 3, just like a geometric series where we can just maybe use the geometric formula and get the sum as well. But here I'm going to be using geometry, okay? And I'm going to be doing that just by looking at each of these terms as areas. So the first term we have there is 1. I'm going to look at 1 as an area, okay? Area of a certain rectangle or maybe a square in particular. And this one as well as an area, an area, an area. So if we are adding areas together, the result should also be an area, okay? Good. And that result is going to be the sum. So here we're having an infinite series. So if you're adding numbers together, you don't even know where it's going to end, okay? But you just know that the denominator are in powers of 2. It's going to be to positive infinity, but in powers of 2. So really, really small terms, okay? Now let's see what we've got. We have the first term to be just 1. So if you want to look at 1 as an area, maybe to some unit or to some squared unit, which I'm not going to consider, okay? I'm just going to put the 1, okay? And we know it's an area. Good. For us to have area of a rectangle to be 1, then let's consider a special case where the length and the breadth are the same, okay? So let's say we have a rectangle like this. Well, make it a very big one. Okay, now if we measure here to be 1, you know, the length of this side, if we measure it to be 1, and then the length of this side as well, 1, what do we have inside here? We will have a perfect square, okay? To get the length or the area of a square like this, we just take one of the sides and square it, okay? Because all the sides are equal. If you square 1, you're just going to have 1. And this one in here is the area, while the red one in red ink, they are the length of the sides. Good. Okay, that is for the first part. That is for the first term there. The area there is just 1. The next one is we produce a rectangle with area 1/2 and add it with the one with the area 1. That is to say, we just want to extend the structure. Okay. Good. Okay, so to get 1/2, we know that 1/2 is the half of 1. That means if this area is 1 like this, half of this area, we can maybe take it here, okay, will be the 1/2. So let's just measure up to this point. This is the half. Okay, from there we can extend this. All right. Maybe this is okay. Notice that from here to here is 1/2. Okay, from here to here is 1/2, while from here to here is still 1. So we measured another 1, and then we got half of it. So if you want to get the area of this new rectangle, it is going to be the 1/2 times the 1, okay? By area of rectangle, we just have the length times the breadth, which is just going to give us 1/2. So the area is written in black, and then the length of the side is written in red. Good. Okay, so what we got? The next one is that we've gotten another area with the 1/2, that's the second term. We want to look at this one, the third term, which is 1/4. 1/4, 1 over 4 is the half of 1 over 2, okay? So if we can take the half of this shape here, okay, the area will be 1 over 4. Good. Let's see how we can do that. Look, from here to here is going to be, you know, if from here to here is 1, okay, you measure from here to here, that will be 1/2 in each, okay, this will be 1/2, right? And that tells us that 1/2 from here to here is 1/2, so from here to here as well is going to be 1/2. So what we're going to produce here is going to be a square, okay, where each side is 1/2, 1/2. And if you multiply the sides together, you're going to have 1 over 4 as the area. So that is just the third term there, which is the third area in this case. Good. So we've produced the first 3 terms, the one with the area equal to 1, the one with the area equal to 1/2, and 1/4. But let's go ahead and check for the fourth term, which is just 1 over 8. 1 over 8 is the half of 1 over 4. So if you look at this area, it is 1 over 4. Half of it, we can take from here to here and just produce half of the entire shape. Good. So this is the half of this one. And by half, we know that from here to here is 1 over 2, okay? Gotten from there. That simply means half of it will be 1 over 4 here. And then from here to here is 1 over 2. Good. So to get the area, we just multiply this and that together. That gives us 1 over 8, which is just the fourth term. All right? Let's look at one more. Okay. So we want to get the next term, which is 1 over 16. 1 over 16 is the half of 1 over 8. So if you want to get the half of this area, maybe in another position, this is going to be from here to here, all right? Let's call that the half. I know it's not really perfect, but it's helpful as well. So already we should know that that place will give us 1 over 16, right? And that can be gotten from here to here is 1 over 4, which is the same thing as this. So this is 1 over 4 as well. And then the measurements from here to here is 1 over 2. That means that the measurements from here to here will be 1 over 4 as well. So if we can have 1 over 4, 1 over 4, that gives us 1 over 16. And we still have a part left here for us, okay? We still have the remaining part of the rectangle. And this remaining part can still contain all these other terms down to, as we add without end. Why? Because the next thing we have to do, notice we started with something, we divided this into 2, we brought this up, go straight, go up, go horizontally, go vertically. So if we can go this, half of it, that will be 1 over 32 here. This one will be 1 over 64. This one will be 1 over 128. This one will be 1 over 256, and so on like that. We're going to be having small squares or rectangles inside there, right? Such that we can't even have a view again. So if we want to kind of zoom this out, you're going to see that the green box is going to be partitioned into other shapes, okay? Stuff like that. So what that tells us is that all these boxes or all these areas can enter the bigger rectangle. So to find the sum of each of these areas, if we can get a structure or a shape that will contain all of them, okay, it contains all of them and only all of them, then the area of that rectangle will be the sum of the areas of each of the smaller rectangles. Good. So to find this sum, or the sum of these areas, we just need to look at what is the area of the entire structure that contains all of them, all right? Okay, so look at this. From here to here is 1, and from here to here is just 1 plus 1. So the rectangle now gives us, the area of that rectangle, the big rectangle, is going to be 1 times 1 plus 1. Okay? And that will just give us 2. So this 2 right here, which is the area of the bigger rectangle, is the sum of the smaller rectangles. Okay, I hope this is helpful as well. Okay, you know, if you can still use this, using the fact that this series converges and it also converges to 2. If you want to look at the common ratio using the first term to be 1, you're still going to end up at 2. All right, great. This was fun, all right? Okay, thanks for watching, and please subscribe to my channel. Make sure to subscribe to my channel. All right, great.